Ever get that feeling, staring up at a really dark, star-smattered night sky, like our universe, this whole cosmic arena that spawned us, is just maybe a little too perfect.
Hmm.
Like maybe the odds of everything aligning just so for life to even pop up are
Yeah.
astronomically, well,
Great.
astronomical.
Mhm.
What if that nagging feeling isn't just like our pattern-seeking brains going wild? What if it's a tiny clue hinting at something much, much bigger? Maybe a whole collection of universes, a multiverse, each with its own set of cosmic rules.
That's exactly the cosmic head scratcher we're going to tackle today. We're diving deep into this really mind bending concept of the multiverse. Is our universe this singular, amazing masterpiece, or is it maybe just one brushstroke on an infinite cosmic canvas?
Yeah, a canvas where each patch could be painted with totally different physical laws, different fundamental constants. It's wild.
It really is.
And look, while we don't have your specific notes right here with us, our mission on this deep dive is really to unpack why this whole multiverse idea even exists in the first place.
Yeah.
Like, what were the initial sparks that got scientists going down this particular rabbit hole?
Right. What's the motivation?
Exactly. And what are the different flavors of multiverses people are proposing? And I guess ultimately, what does it all mean? Whether we're in a solo universe or this teeming cosmic metropolis,
Yeah.
what are the implications for how we understand, well, everything?
Okay. Let's do it. Hold on to your hats, folks.
So maybe start with the basics.
Yeah.
Why even consider a multiverse? It's not the most obvious idea, is it?
No, definitely not. It's not like you just, stumble upon evidence of another universe in your backyard shed or something.
No, not quite. It seems like the idea sort of crept in maybe through the back door of other theories, almost like a consequence.
Yeah, that's a good way to put it. Some theories just naturally led to contexts where our universe might just be one of many, and maybe each one got slightly different settings for its physical constants.
Like a cosmic control panel with infinite knobs, and each little twist creates a whole new reality.
Precisely. And then you've got things like string theory coming into the picture.
Right. Brains and bulk and all that.
Exactly. String theory suggests our familiar four-dimensional universe might be like a membrane, a brain existing within a higher dimensional space, the bulk.
Okay.
And what's really fascinating there is the possibility that there could be other brains out there too.
Floating around in the bulk.
Uh-huh. Maybe even bumping into each other. Some theories even suggest these, like cosmic fender benders, could be the spark that ignites big bangs, birthing whole new universes.
Wow. Okay, that's one angle. But then there's this whole fine-tuning thing, right? The anthropic principle.
Yes. And this is where it gets really interesting, I think, the anthropic principle.
Yeah.
It's this observation that our universe seems, well, weirdly tailor-made for life.
Yeah, like all the fundamental constants, the strengths of forces, gravity, electromagnetism,
Yeah.
they all seem to be dialed in just right. If you tweak them even a tiny bit.
Poof. No stars, no complex chemistry, certainly no us having this conversation.
Exactly. No podcasts.
Yeah.
And the multiverse offers a potential out for this apparent cosmic luck.
Right. The logic is kind of compelling in a way. If there's a truly vast, maybe infinite collection of universes out there, and each one gets a random roll of the dice for its physical parameters.
Then it becomes almost inevitable that some of them, just by chance, would happen to have the settings that allow for complexity and eventually life.
Exactly. So the fact that we find ourselves in such a universe isn't some miracle, it's just selection bias. We couldn't exist to observe any of the other, presumably much more numerous universes where the conditions aren't right.
So our existence itself kind of filters the possibilities we can see.
Precisely.
Yeah.
It's definitely indirect evidence, we're not seeing these other universes directly, but it's a powerful argument for some physicists.
It's like winning that impossibly huge lottery. You'd think it was a miracle if you were the only one playing.
Yeah.
But if billions and billions of tickets were sold across countless parallel lotteries, well, someone was bound to win eventually, right?
That's a great analogy. And a prime example people always bring up is the cosmological constant.
Ah, yeah, the dark energy thing.
Right, this mysterious energy that seems to be making the universe expand faster and faster. Its measured value is just bizarrely small compared to what our best theories in particle physics predict it should be, like orders and orders of magnitude smaller.
Which is a huge puzzle.
A massive one. And the multiverse offers a potential explanation through this anthropic selection. Maybe only universes with a really tiny cosmological constant like ours can actually allow gravity to pull matter together to form galaxies and stars in the first place. In universes where it's large, maybe everything just flies apart too quickly.
So again, we could only exist in a universe where it happened to be small enough.
That's the idea. And it's really crucial here to see how cosmology, the big picture stuff, and particle physics, the tiny stuff, are getting tangled up together.
Yeah, they seem deeply connected when you start asking these fundamental questions.
For instance, some of these anthropic arguments have actually spurred potentially testable predictions, like things related to vacuum energy that maybe we could probe with experiments at the Large Hadron Collider, the LHC.
So it's not purely philosophical hand-waving. There are some potential empirical links, however tentative.
Potentially, yes. It shows how these ideas, even if they seem way out there, can sometimes circle back to actual physics we can try to test.
Okay, so this multiverse idea feels super modern, very sci-fi, cutting edge.
Yeah.
But you mentioned earlier, and our sources point this out too, that the whole notion of our universe being maybe bigger or different than we thought, that actually has a history, right?
Oh, absolutely. It's not the first time our cosmic horizons have, dramatically expanded. There's been this fascinating evolution. Well, think way back. First, we thought Earth was the center of everything, the geocentric model.
Right, standard stuff.
Then you get folks like Galileo with his telescope, and suddenly, maybe the Earth isn't the center. Maybe the sun isn't even that special. He even figured out the Milky Way, that hazy band across the sky, wasn't just celestial fog.
It was countless individual stars, just incredibly far away.
Exactly, which just blew the doors off the perceived scale of things. That itself was a huge expansion of the universe in people's minds.
And then didn't Kant take it even further?
He did, yeah. Decades later, Immanuel Kant proposed that some of those fuzzy patches astronomers were seeing, the nebulae, weren't just gas clouds inside our own Milky Way.
But entire island universes, as he called them, like whole other galaxies just like ours, but way, way out there.
That was his radical idea, and it's kind of amazing to think even someone like Einstein, when he first cooked up general relativity,
Yeah.
his initial model of the cosmos assumed the Milky Way was the entire universe. That was the prevailing scientific view for a while.
Wow. So Hubble's discovery of other galaxies really was another massive shift.
A monumental one. So this historical perspective is super important, I think. It reminds us that our definition of universe has already changed radically. What we currently call the universe might just be one part of something much bigger, just like the Milky Way turned out to be one galaxy among billions.
It definitely encourages a bit of humility about our current understanding, doesn't it?
It really should. Keeps the mind open.
Okay, so if we're entertaining these possibilities of more universe, our sources brought up Max Tegmark's classification system for the multiverse. That sounds like a useful way to get our heads around the different levels.
It is, yeah. Tegmark's levels provide a really handy framework. Let's start with level I. This is sometimes called the many worlds, or maybe better, the patchwork multiverse.
Okay, patchwork.
This one is probably the least outlandish conceptually. It basically comes from the idea that space is likely infinite, or at least incredibly vast, far beyond our cosmic horizon, the edge of what we can physically see, because light hasn't had time to reach us yet.
Right, the observable universe has limits.
Exactly. So if space goes on forever, or is just mind-bogglingly huge, then statistically, somewhere out there, far beyond our horizon, the initial conditions are bound to repeat. So there could be other regions of space, other patches that look essentially just like our observable universe. Same physical laws, same constants.
But just different arrangements of matter, like everything happens slightly differently over there.
Pretty much. So yeah, in principle, you could have another Earth, maybe even another you out there living a slightly different life.
Whoa. Okay, maybe in one of them I did stick with learning the trombone.
Huh. Could be. It's a bit mind-bending, but it flows pretty naturally from standard cosmology, assuming infinite space.
Okay, that's level 1. What's level 2?
Level 2 gets a bit wilder. This proposes other post-inflation bubbles. It comes from the theory of cosmic inflation.
That super rapid expansion phase right after the Big Bang.
That's the one. Some models of inflation, particularly eternal inflation, suggest that inflation didn't stop everywhere at once. It might have stopped in our region, allowing our universe to form, but continued raging in other regions.
Okay.
And in those other regions where inflation eventually did stop, maybe much later, new bubble universes could form.
Ah, so like bubbles forming in boiling water, but on a cosmic scale.
Sort of, yeah. And the key thing about these level 2 universes is that while they might share the same fundamental equations of physics from whatever underlying theory spawns them, like string theory maybe.
They could have different outcomes.
Exactly. Different physical constants could freeze out differently in each bubble. They might end up with different fundamental particles, maybe even a different number of spatial dimensions.
Wow. Okay, so level I is more of the same stuff, just arranged differently. Level 2 means the actual rules could be different next door. That's a big leap.
It's a significant step up in strangeness, for sure. Then you get to level 3.
Level 3, what's that one?
This is the many worlds interpretation of quantum mechanics. Now, this often gets confused with level 1 because of the name many worlds, but it's quite different.
How so?
Level 3 doesn't posit other universes existing far away in physical space. Instead, it suggests that every time a quantum measurement or interaction happens where a particle could, say, spin up or spin down, the entire universe
Splits?
Yeah, into parallel branches, parallel storylines. In one branch, the particle spins up. In another identical branch, it spins down. Both outcomes happen, just in separate realities that then evolve independently.
Okay, hang on. So these aren't other bubbles out in the cosmos, but like parallel versions of our universe constantly branching off based on quantum events.
That's the core idea. Our source mentioned this. It doesn't really add fundamentally new kinds of universes beyond what levels I and 2 might contain, but it creates countless different quantum versions of them.
And this relates to that weird wave function collapse problem in quantum mechanics.
Exactly. The standard view says a quantum system exists in a superposition of states until measured, then its wave function collapses into one definite state. But how and why it collapses is a bit mysterious.
Right.
The many worlds interpretation just says, forget collapse. The wave function never collapses. All possibilities encoded in it become physically real, just in their own separate branches of the overall universal wave function.
Okay. My head is starting to spin a little. That feels very counterintuitive to our everyday experience of one reality.
It absolutely is. It challenges our basic notion of a single objective reality. Which brings us, finally, to level 4.
Level 4. Please tell me this one is simpler.
Nope. Sorry. Level 4 is arguably the most radical and abstract of all. It's called the mathematical democracy, or the ultimate ensemble.
Mathematical democracy. What does that even mean?
It's the idea, proposed by Tegmark himself, actually, that all mathematical structures that are logically consistent actually exist physically.
Wait, all of them?
All of them. Our universe, with its specific set of physical laws and constants described by mathematical equations, is just one such mathematical structure that happens to be complex enough to contain self-aware substructures, like us.
So any set of equations you can write down, as long as it's mathematically sound, describes a real physical universe somewhere in this level 4V multiverse.
That's the proposal. It completely flips the script. Instead of asking why our particular mathematical laws describe reality, it asks why any mathematical structure wouldn't correspond to a physical reality. If it can be described mathematically, it exists.
A universe made of cheese, a universe ruled by rubber chickens, a universe where 2 plus 2 equals 5. Okay, maybe not that one if it's inconsistent.
Yeah.
If the math works, it's real.
Essentially, yes, if the mathematical structure is consistent. It's a form of extreme Platonism, the idea that mathematical concepts have a real existence. Level Viavy says mathematical existence is physical existence.
Okay, brain officially melted. That is a lot to take in. But surely with ideas this wild, there must be some serious pushback, right? Some major criticisms.
Oh, absolutely. You're spot on. The multiverse hypothesis, in all its forms, faces some pretty significant challenges and criticisms.
Like what? What are the big ones?
Well, one of the most common ones you hear is the wastefulness argument. It kind of invokes Occam's razor, the principle that usually the simplest explanation is the best one.
Right, don't multiply entities unnecessarily.
Exactly. And postulating trillions upon trillions, maybe infinite numbers, of unobservable universes just to explain some features of our own. It strikes many scientists as incredibly wasteful and complex. It's adding a huge amount of theoretical baggage.
Plus, it's just the sheer weirdness factor, isn't there? It's so counterintuitive.
Definitely. That's a psychological barrier, perhaps, but a real one. And connected to the wastefulness is the core problem you hinted at earlier, observability.
Yeah, if these other universes, especially levels 2, 3, and 4, are fundamentally disconnected from ours, how could we ever hope to detect them? How could we prove they exist?
That's the million-dollar question, isn't it? Our source brings this up. Claims about truly separate, causally disconnected multiverses might actually cross the line from physics into metaphysics precisely because they seem untestable, maybe even unfalsifiable.
Unfalsifiable, meaning you couldn't even prove it wrong.
That's the worry. Falsifiability is, a cornerstone of science. A theory needs to make predictions that could, in principle, be proven wrong by experiment or observation.
Okay.
But if the multiverse ensemble is so vast that any observation we make is bound to occur in some universe within the collection, how can you ever disprove the multiverse idea itself? It risks becoming an explanation for everything, which means it explains nothing specific.
You need a theory of the multiverse, not just the multiverse itself. Something that predicts the properties of the ensemble in a testable way.
Exactly. We need a mechanism, maybe from string theory or eternal inflation, that doesn't just say multiverse exists, but makes specific, testable predictions about, say, the distribution of constants or other features we might observe in our own universe.
And then there's this measure problem you mentioned.
Yeah.
That sounds complicated.
It is, yeah. It's a really thorny technical issue, especially for level 2 multiverses arising from eternal inflation or the string theory landscape. The landscape, for example, might predict a staggering number of possible vacuum states like 10 to the 500, or even more, each potentially corresponding to a universe with different physics.
Okay, a huge number of possibilities.
But how do you assign probabilities? If inflation goes on forever, creating infinite volumes of different types of universes, how do you compare them? Do you count universes? Do you measure by volume? Do you count based on how many observers or galaxies they produce?
And different ways of counting give different answers.
Drastically different answers, potentially. This ambiguity in defining a probability measure makes it incredibly difficult to make concrete predictions about what we should expect to observe in our own universe, even if the underlying theory is correct.
Our source also mentioned something about the principle of mediocrity and potential pitfalls like the doomsday argument. What's that about?
Right. The principle of mediocrity is this sort of assumption that we're probably not special. Our location in the universe, our time, maybe even our civilization should be fairly typical among all possibilities.
Seems reasonable on the surface.
It does, but applying it can lead to some weird, even disturbing conclusions. The doomsday argument, for instance, tries to use this principle assuming you're a random observer among all humans who will ever live to calculate the probable future lifespan of the human race. And the results often suggest a surprisingly short future. Yeah. It highlights how tricky it is to apply these kinds of statistical arguments, especially when you're dealing with potentially infinite sets and you don't have a solid way to define what typical even means in a multiverse context.
Okay, so lots of challenges. Multiverse is definitely not a done deal. Are there other scientific ideas out there that try to explain things like fine-tuning without needing all these other universes?
Oh, yes. Absolutely. Science is always exploring alternatives. For the very early universe, for example, there are pre-Big Bang scenarios, cyclic universe models, things that try to explain the smoothness and flatness of our universe without invoking inflation, and thus potentially without eternal inflation's multiverse.
Okay.
And in particle physics, while the multiverse plus anthropic selection is one way to tackle the fine-tuning of things like the Higgs field's value or the cosmological constant.
There are other approaches.
Yes. For instance, there's something called the strong CP problem in particle physics, another fine-tuning puzzle. One leading proposed solution involves a hypothetical particle called the axion. That's a completely different type of explanation, relying on new symmetries or particles within our universe, not invoking other universes.
So the search is still on for more fundamental theories within our own universe that might explain these constants naturally.
Definitely. Many physicists hope we'll find deeper principles or symmetries that dictate why the constants have the values they do, without needing to appeal to an ensemble of possibilities.
It sounds like a core part of the debate is really about the scientific method itself, isn't it? Like, are anthropic arguments based on our own existence, actually legitimate tools in science?
That's a huge part of it, yes. It's an ongoing, sometimes quite heated discussion. Some argue, as we noted, that anthropic reasoning can be predictive if used carefully, maybe predicting relationships between constants or suggesting where new physics might lie.
Like that principle of living dangerously idea.
Yeah, the idea that maybe anthropically selected parameters aren't just randomly anywhere in the allowed range, but might lie right at the edge, just barely allowing life. That's a potentially testable prediction in principle.
But others are wary.
Others remain very skeptical. They worry that relying on anthropic explanations might be seen as giving up on finding a deeper, more fundamental understanding, that it could stifle the search for the underlying reasons why the universe is the way it is.
It really does blur the lines between physics and philosophy sometimes.
It absolutely does. Questions about the nature of reality, the limits of what we can know, our place in it all. The multiverse discussion forces us to confront these very deep issues.
Okay, so let's try and pull this all together. It really sounds like the multiverse is this incredibly complex, multifaceted idea. It bubbles up from different areas of theoretical physics, cosmology, string theory, quantum mechanics.
Right, and it's fundamentally an attempt, a really ambitious one, to grapple with some of the biggest mysteries out there, especially this apparent fine-tuning of our universe for life.
It offers some potentially neat explanations, but wow, it comes with a whole suitcase full of challenges.
The big suitcase, yeah. Testability,
Yeah.
measure problem, philosophical objections. It's far from settled science.
And what strikes me is how it pulls everything together.
Yeah.
Particle physics, cosmology, quantum theory, even philosophy. It really shows how interconnected these fields become when you push to the very edges of knowledge.
It really does, and it underscores how much our picture of the universe has already changed and how much it might still change. It's a reminder that our current understanding might just be one frame in a much longer movie.
Absolutely. And maybe for you listening, it's worth thinking. If the multiverse is real, how does that land with you? Does it make our universe feel less special, just one random ticket out of trillions?
Or Does it do the opposite? Does it somehow amplify the wonder, the sheer unlikeliness, the preciousness of this specific cosmic lottery win that allows us to be here thinking about it all?
That's a really powerful thought to end on. If our universe is just one possibility among maybe an infinite number, what fundamental questions does that leave you pondering about reality and about our own, perhaps incredibly improbable place within it all? Thanks for taking this deep dive with us today.